I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcast. Thanks again for joining us for today's presentation, MSDN Webcast, C# 2010 Soup to Nuts, Part 9, Basic Debugging. Now it's my pleasure to introduce today's presenter, Bill Steele, Senior Developer Evangelist for Microsoft. Bill, you now have the floor.
Thank you, Sydney, and welcome back, everybody, to this ninth in our C# Soup to Nuts series. Today we're going to be talking about debugging. Debugging your application. What is debugging is basically the whole talk today. But in order to figure out what debugging is, I guess we have to start off with what a bug is. So we'll start off with a definition of a bug. We'll then talk about how do we actually remove bugs from applications, how do we define them, how do we use Visual Studio's built-in tools to actually help identify the bugs and see how Visual Studio can actually help us in not only determining what the bug is, but how we can actually resolve the bug. And then we'll look at some of the tools inside of Visual Studio, specifically the breakpoints and the ability to use some of the various windows inside of the Visual Studio environment to help us understand the status of our application while we are actually in debugging mode. So let's start off with what is a bug. A bug is, very simply put, a flaw in a piece of software. And that flaw is generally related to an error in coding. Either the developer incorrectly typed in a statement, or the business rules, the business logic actually has a fault with it that causes the application not to perform as expected. Not necessarily the application might actually be doing exactly what it's told, but it isn't exactly what the designer or developer of the application intended for it to do. So a bug is simply a flaw in the program. Now, most applications, very large applications generally, are going to contain a few invalid instructions, or issues with the application that can be considered a bug. And in those cases, generally what you're going to find is that the way most software development works is that there is an acceptable amount of issues in an application. Some people tend to disagree with that, but when you have a larger application like that, if you're continuously finding bugs and you're not shipping any products, you're going to wind up with an application that takes 27 years to develop. So what you have to do is in your development lifecycle processes, you have to come up with an acceptable amount of issues. For example, it might be that there might be on an application that has 50 developers on it. It might be acceptable to have risk levels. So you have a high, medium, and low risk level of a bug, and no high risk, for example, maybe 1 medium and maybe 5 low risk bugs or something to that effect. It simply depends on the application and what kinds of business requirements that your particular application is fulfilling. Now, there are several different categories of bugs. So I talked about a bug being generated by a user or a developer incorrectly typing in a line of code. A bug might be generated simply because the business rules are in violation. The business rules weren't correct, for example. There are other types of bugs. Some of them are kind of interesting that could be introduced, for example, by a compiler. So you, as a developer, might type in the correct line of code, but as the application gets compiled, it gets compiled into the assembly language that's running on the computer, and there might be a flaw either in the compiler or in simply the way the compiler interprets it, the code. So there's some interesting things that you can run into there. The actual term for bug actually has an unknown origin, but it's been used to describe issues in computers, pretty much since the beginning. However, it was in use way before the computer was ever invented. So interestingly enough, Thomas Edison actually has quite a few inventions, and during his development of some of his projects, he quite often used the term bug to describe a discrepancy in the way the unit was supposed to function. And a lot of people tend to confuse a security hole with a bug. Interestingly enough, a security hole is actually not a bug, as you would expect it to be. And I personally don't consider a security hole a bug. It's actually a when you think about an application, you develop an application for one particular task in mind, and you build all of your rules around that task. And you build all your code to support that task, and that's developing an application. Now, it turns out that sometimes those applications can be utilized for unintended purposes, and those unintended purposes can actually be exploited by malicious developers to their advantage. And that leads to some of these security holes. So this would be synonymous with like a developer of a car, for example, building a car, designing it, and then selling it, and then finding out later on that a malicious driver bought the car, and instead of driving on the interstate like the car was designed to do, they took it through a fairground with a whole bunch of people in it, and caused a lot of mayhem. And that's using a car that was perfectly designed and perfectly suited for its natural environment in a scenario that it wasn't intended for, which could cause a lot of problems. So that's an example of a security hole as opposed to being a bug. So you want to be careful with the terms between those. So what is debugging? Well, debugging is a very simple act of removing any issues within the code. And the whole process of debugging an application is basically identifying and eliminating those software errors that can occur in code. Now, the term debug an application actually is attributed to computer users. In fact, one of the very earliest computers was the Mark II computer. They actually have the first documented use of the term debug that's known, which occurred in 1947. When a computation that they were running started giving back erroneous results, and in searching through everything, they actually physically found a moth stuck in one of the relays, causing that relay to fail, which was causing the erroneous data. So they debugged the application, if you will, by removing the moth from the relay and restoring the application to its working self. So that was the first use of the term debugging an application. So how do we debug applications? Well, it turns out when we're using Visual Studio, we have a great set of tools available to us. Visual Studio has debugging support built in whenever you press the F5 key to run your application. It automatically spins up a debugging processor that kind of sits along the side of your application, and it monitors the state of your application, and it allows you to not only see what's going on inside the application, but also to take control of the application through the debugging process. When an error occurs within your application, for example, when a mathematical overflow or something like that occurs, that the application has not been designed to deal with, Visual Studio will actually intercept any exceptions that are thrown that were unhandled by your application, and it'll display a very nice friendly dialog box letting you know that that particular error occurred and some suggestions on ways to actually fix the error. So that's actually one of the very first things that you're going to start using inside of Visual Studio from a debugging standpoint is you're going to use its ability to understand what a program is supposed to do, and in an exceptional case, it will actually tell you what the problem is with your application and suggest ways to fix that. So let's go ahead and pop into our first demo and actually take a look at that dialog box that Visual Studio is going to give you and let you see what kinds of information are also available in that dialog box. Now, when I move to my next screen, it's going to take you out to my view sharing demo. And my screen is set to 1024 by 768. So if your screen is that resolution or higher, you can press the F5 key on your keyboard and maximize your display so you can see my entire screen. When I'm done with the view sharing demo, you can actually press the F5 key again, and it'll return you back to the normal live meeting console window. And as always, please feel free to ask me any questions in the Q&A panel. And I see those on my panel here. Whenever I come back from the demos that I do, I'll go ahead and answer all of those questions that you have in the queue verbally. All right, so into our first demo. Let me just show you what I've built so far. I've built a very, very simple Visual C# application. It has just a basic window with two numeric, basically text boxes that allow me to type in numeric values. I have a label over here that allows me to display the answer, and I have a button that allows me to initiate whatever calculation I'm going to perform. And in this case, what I have is I've got some code here. I've defined 3 integers that allow me to store some values. I have a method down here that's called getValues that simply reads the top and the bottom numbers, text boxes from that form, and it stores them in the variables A and B. And then in my button click event handler, I actually have a line of code that first off gets those values and populates A and B. The second line actually executes an expression, A divided by B, and stores that value in C. And then we go ahead and display the answer in the answer label text box, answer label on the form. So let's just go ahead and run this and see that 35 divided by 5 is 7. So when I click calculate, it calculates the answer. And if I change this to 7 and recalculate, we get a 5. So we can see that our math is correct here. Now, what I haven't taken care of, though, is the exceptional case where the value of B could be 0. And we all know that you cannot divide a number by 0. So in this case, if I plug in the value of 0 and I try to divide 35 by 0, I'm actually going to get, after a small pause here, an exception being caught by Visual Studio. So instead of my application actually crashing, Visual Studio paused my application and it's displayed the line of code that's causing the issue. And it's telling me that, hey, you've attempted to divide by 0. So here you can clearly see that we've thrown a division by 0 exception, and it's describing to me what the exception is. And not only is it describing what it is, it's also suggesting ways of me fixing it. So here it says make sure the value of the denominator is not 0 before performing the division operation. And you'll also notice that that's a hyperlink. And if I want to, I can click on that hyperlink, and that'll go ahead and launch the help system, whatever the default help system that we have in Visual Studio is. And in my case, I have it launching the external help first. And it tells me that here's the division by 0 exception. And because I'm in C#, it also tells me a couple other interesting things. Dividing a floating point value by 0 results in either positive infinity, negative infinity, or not a number, according to the rules of the IEEE. Floating point operations never throw an exception. That's pretty handy information because it allows me to actually think about my application in a new way. In fact, I can go back to my application, go back to my C# Express here, and realize that, yes, I was actually dealing with integers, but it turns out if I use floating point values here, then this exception would never get thrown. So we can change this simply to something like a float. So now instead of using integers, I'm using 3 floating point values. When I rerun the code and I type in a 0, now I get the value infinity because 35 divided by 0, according to the IEEE, is actually infinity. So you have, that's the answer that you get back. There's other ways of handling this. For example, I could simply check to see if B is not equal to 0, then go ahead and do the calculation. Something like that. And that avoids that problem as well. So here we would do that. And then I could simply say, well, okay, well, let's go ahead and display the answer in here because that is correct. Otherwise, get their hands on the right key here. Otherwise, else, this.answer, that text, division by 0. There we go. So in this case, I'm checking the value to 0, checking the value against 0, making sure it is not 0 in this case, right? So the exclamation, if we remember our expression evaluator, this is the not equal to 0. And when we run the code now, if I plug in a value 0, I get, because I still have this line of code in there. Let's take that line out, and now we'll get division by 0. So it's actually checked the value of 0. By the way, the reason this displayed 0 is because it made this conditional check, fell down to here, went ahead and processed this line, then processed this line, but we only assigned the value C here. When we first define the value C, it has a default value of 0, so that's why it displayed 0 incorrectly. So that gives you an idea of how helpful the debugging information is displayed when an exception is thrown inside of Visual Studio. Now, one thing to point out here, there is a way of dealing with this in a totally different way, and that's actually doing the catching an exception. But I don't know if you noticed it, but when I actually ran the code and it threw the error, it actually took several seconds for it to come back to me to tell me that there was an exception. And the reason for that is exception handling is a very, very heavy process. It has to capture all that data. It has to construct a new exception object, and then process that and then display that to you. So it takes a lot of effort from a computing standpoint to actually display an exception. It takes a lot less effort. In fact, this is a single instruction to the computer, one single instruction in the computer to actually avoid the exception altogether to begin with. So you always want to make sure if you have a way of logically dealing with an exception before it occurs, it's much more efficient to deal with it before it occurs than after it occurs. So that's something you want to think of when you're building an application in C#. Okay, back over to my window here. I have a statement in here from Martha that says comparing a float to 0 is bad practice, but actually that's irrelevant for the demo. We actually are comparing, and our code is actually doing integers. The idea was that you could see multiple ways of dealing with the issue depending on whatever the business rules dictate. In our case, we actually used we changed the values back to ints, and then we compared them to 0, and there's absolutely nothing wrong with doing that. Okay, breakpoints. So one other issue, one other cool technology that we have when we're dealing with building an application is the ability to set what's called a breakpoint. And a breakpoint is basically indicating in our code that we would like the application to pause at a particular point so that we might take some other actions. We might inspect the values of the variables stored within it, for example. Or we might even want to be able to modify the code to do some various different types of scenario testing as we're building our application. So a breakpoint is actually a very, very handy feature to add. Now, I do want to point out that breakpoints within Visual Studio's Express editions are very simple. If you're using the Professional Edition of Visual Studio or above, breakpoints can become very, very powerful because with a breakpoint in Visual C# Express, you're basically telling the application that you want to stop. And there is no criteria or anything else available to you beyond that. But when we're dealing with a breakpoint within the more advanced versions of Visual Studio, instead you actually get a lot of power around being able to control when the breakpoint fires and how the breakpoint fires. And not only can you do that, but we also have other types of breakpoints beyond just a simple pause. So there's a much more advanced talk, if you will, available around the more advanced versions of Visual Studio. But for the demos that we're doing today, we're doing them in C# Express. This will work in any version of Visual Studio. So the breakpoint that we're going to set, we're basically going to choose a line of code, and we're going to ask Visual Studio to pause execution of the application when it reaches that point in our code. And the way we do that is we simply place the cursor on the line of code that we're dealing with, and then we're going to press the F9 key. The F9 key will then highlight that line of code, giving us an indication, actually gives us two indications, that there is a breakpoint set on that line. And that whenever you press the F5 key or run the application in debugging mode, what will happen is whenever the debugger is attached to the process, it'll go ahead and stop executing the code and return us back to Visual Studio at that particular point. We can then at any point hit the F5 key to resume the application or press some of the other keys. In this case I say F11, but there are several other keys that we can use to actually move through the application at varying speeds. One of the other features of Visual Studio is this thing called the watch window. And the watch window allows us to, while we're in a breakpoint mode, to view the status of various objects and variables that we have within our application. When we actually are building an application, a lot of times we might be dealing with complex objects, and we would like to be able to pause the application at a particular point and actually see all of the different aspects of that, those complex objects. And it turns out the watch window is actually a great feature in Visual Studio that allows us to do that. Not only does it allow us to see the application or those variables or those objects, but it also allows us to alter them. So the watch window has a feature that allows us to edit the values, for example, of a variable while the application is in its pause state. And this can be really, really handy for more, advanced debugging scenarios. So let me go ahead and show you the breakpoints in the watch window, and we'll see how they work together to help us debug an application. Okay, back over to our demo here. We have this method up here called getValues, and this method is broken out down here into where we're assigning two integers from the text labels that we actually had on the main form there. So whenever you click the button, I call the getValues method first. And what I like to do for debugging my application is I'd simply like the application to go ahead and stop at this point and let me see the values as they come back out of this method. So to do that, I'm just simply going to press the F9 key on that line, and that places a red highlighting on that particular line. Now, red is the default colors. You can change them to whatever you want, but the default is red highlighting. And then we get the red ball over here indicating a debugging state. Now, I can also go to any other line of code, and over here on this gray column where the ball is, I can simply click on any of those lines as well and place debugging statements as well, breakpoint statements there as well. So by clicking them again, you can actually remove them. So you can have multiple breakpoints when you do that. Now, when you have multiple breakpoints, or when you have a breakpoint like this, and you press the F5 key or just hit the green arrow to start executing the application, what will happen is Visual Studio and the application will launch just fine, but when you press the Calculate button and it encounters that breakpoint, it's immediately going to return back over to Visual Studio so that we can see what's going on inside of the application. And you can see right away that it's showing me this locals window and this watch window. And this watch window actually has three values in it that I've already preset up. As a matter of fact, I can go through here and delete all the watch, basically take each one of these and remove it. And if I wanted to see a value, for example, in this case, B is 0, let's go ahead and add that. I can choose Add Watch, and that'll place that down there. But you'll also notice that I can actually just hover over the values, and when I hover over them, it gives me this little tooltip kind of inspector window that lets me see the value of those objects before they're actually being used for anything. So in this case, my breakpoint is set here, and I also have the line now highlighted in yellow indicating this is the line that's going to execute next. So here's our next statement that's going to execute. And while I'm in breakpoint mode, while we're looking at this, you'll notice that I have a toolbar up here that has a few additional functions set on it. The first one is the continue that we had the run before. This is the debug window that allows us to continue executing our code. So if I simply hit the green arrow, the application will continue to run, and it'll go ahead and perform the calculation as expected. If I go back into break mode, I can actually stop executing of the application altogether simply by hitting the stop button or hitting Shift F5. The next one is actually Show Next Statement, which actually just highlights the next statement. So if I was hidden somewhere, I can actually choose this, and it'll always bring me back to and center the current active statement. So no matter where I'm at in my code, I could be hidden somewhere else. I can hit that button, it'll take me right back to that line of code that's going to execute next. The next thing that I can do is I can actually step into a function or a method that I might have. So in this case, I have this subroutine that's called getValues, and what I'd like it to do is I'd like to step into this code because I'd like to see this getValues method processed individually as well. So what I can do is I can hit that button there or just press F11, and every time I press that, you see that it drills down into that line of code and lets me process that line of code. So here we can see that this value has read the text value 35 from the screen. It's parsed it into an integer, and it's placed it into this variable called A. So now A contains the value 35. Now, interestingly enough, B contains the value 5. We've already hit this one as well because it's already processed this. Let's go ahead and move on. And now we can move back up to here, and it returns back up to this line. Now, in this case, it's already executed those values. So when we hover over them, or when we look down inside our watch window, we can see that those values are already assigned. It turns out that we have 35 divided by 5, so we know that that answer is going to be 7, and we can see that. It's kind of calculating this ahead of time for us. As a matter of fact, it's calculating them because we've already assigned them the first time. But I can go through and change these. So here's the value 5. Let's go through here, and I can right-mouse click on it and choose Edit Value, and let's change this to 7. So now when I change that to 7, we see it's highlighted in red, indicating that this value has changed. So now when we come back over here, we see that the value B is now 7 when I hover over it up here. And if I go ahead and step into this code here, boom, our value C now becomes 5 because 35 divided by 7 is actually 5. Now, this actually, I just showed how this actually calculates that. So when I go ahead and hit F5 to continue the execution of this, we see we're going to get 35 divided by, even though it says 5 equals 5, remember we changed the value under the covers to 7, but we didn't reflect that here. We didn't reflect that on the form. So we have a way to modify the values basically from within this watch window. Now let me go ahead and run this one more time and show you one other cool aspect of this. If I hit these other buttons here, notice that this one was step into, and when I did step into, it processed all these values. The one over from that, F10, which is step over. So if I go back down to here, watch what happens when I hit step over. Notice that it jumped immediately to the next line of code. However, it did process the values. It did load the value A and B, and we can see that our value is back to 5 because it loaded it back from the form. So F11 allows us to step over that code and continue on. Now, the one last one that we have is what we call step out of. And in this case, what it's going to do is we are in a certain block of code, and the step out of will actually step all the way out of that block of code as if you finished it. So, for example, if I go ahead and step into this line of code, I'm now in this get values method. Maybe I just wanted to do the very first line, and once I'm done there, I want to go ahead and resume back up to here. I can press this key, step out of, and that'll go ahead and take me back up to those values. So it'll basically finish out all of the rest of this and resume me back up to here. One other cool little aspect of this, actually there's two others that I want to show, is that we have in the debugger the ability to change the statements that we're processing. So in this particular case, we can see the current statement is here, indicated by the yellow arrow. And as I step through my code here, maybe what I want to do is change the value of this, but this line of code is already processed. So what I can actually do is I can go to my immediate window here, and I can say, well, B equals 15, A equals 45. So I basically just reset the values of A and B here. So when I hover over them, you can see I have the values of A and B. I can then take my green or my yellow arrow here, and I can drag it back up to this line of code here, and that sets the next statement back up to this line of code. And then I can process that again. And now you see C, the value C is now 3, which is 45 divided by 15. So I've reprocessed that line of code, and now I can continue on. And this allows me to actually change the values of this code, test new scenarios at the same time while I'm actually in the process of debugging it. So you can get more advanced scenario testing. Maybe you want to, you're not using it like a good Visual Studio testing environment. You're using the Express editions that don't have the powerful test tools, but you still want to be able to test various scenarios. This allows you to do something like that. As we're going through here, we can actually put breakpoints, even though the application is running in this case, and I've even run it, through code a couple times. You can still press a breakpoint after the fact, and then hit the calculate button again, and it'll still hit that breakpoint. So you can turn them on and off whenever you want to, and it will allow you to continue to process that. So that's a real handy feature with the breakpoints. Okay, back over to my window here, my slide deck. One other aspect of debugging an application happens to be built into the .NET framework, and that's called the Debug class. Within the System.Diagnostics namespace is a class called Debug that contains a bunch of features that allow us to do some additional debugging information in our application. So, for example, a lot of times you don't want to stop the execution of your application. Maybe it's timing dependent or something like that. But you want to see what's going on inside under the covers. Well, it turns out we have the debug.write statement that allows us to write information out to Visual Studio's debug window. And the debug window will display that text without interfering with the operations of your application. By using a debug write and its sister, the debug write line, you can actually send information out to any kind of listener that's listening for specific debugging, what we call trace information. And I'll show you not only the how to use the debugging information, but how to extend that later on for your own custom use. A couple other debug statements that are important to us are ones around the ability to actually force the application to deal with an issue. So remember our division by zero error that we had earlier. Well, it turns out we have multiple ways of checking that, but in some cases you want to be able to handle this through the debugging system, and you need to let the debugging system know that this error is about to occur and that you're preventing it from occurring through this assertion mechanism. So what happens is with a debug assert and a debug fail, technically they're both the same thing, but with a debug assert, you're going to test for a condition, and if the condition is false, then you want the application to fail. With a debug fail statement, we're just forcing it to fail no matter what. There is no condition. It's just going to stop the application with the assertion that the app has failed. So we have a couple different ways of dealing with that. So let me go ahead and show you the debug statements and how they can be useful in our applications. So back over to my demo machine. So down here in our get values, first off, let me just go ahead and run this and show you one aspect of this that will help you explain what we're talking about here. I'm just going to go ahead and put a breakpoint right there on the answer label. And when I hit calculate, it's actually showing me the line of code that's here. I have these in my watch window here. I have the value for B, and I can add the value for A, for example, and the value for C, so I can see all of those. But with these there, I also have this immediate window over here. And the immediate window is where I actually changed the values of those before. But the immediate window actually allows me to process commands immediately. So, for example, I can say, well, just like I did before, B equals 15. That's an immediate statement that I've just executed on this. I can even say question mark B or question mark A, and it's basically saying, hey, show me the value of these. This is information that I could actually use inside my application, to help debugging it. But it turns out we have this other window over here called output. And output is basically the output of the application. And you'll notice that we have a lot of debugging vhost.exe stuff. This vhost.exe is actually the process that's attached to my application that allows the Visual Studio environment to actually intercept what's going on and tells me what's going on inside here. And you see that the vhost environment actually gives us a lot of useful information about the debugging state of it. Well, it turns out that with the debugging windows enabled in Visual Studio, that I can also send data to this output window. So let me go ahead and stop the application and just show you a couple of examples of that. Here we have, let me do spell it correctly, System.Diagnostics.Debug.write test output. So in this case, I'm just writing the words test output out to whatever my debugging window is. So now when I run the application, when I click on this, you'll notice that in our output window we have this text test output. That's because I just told it to blindly write that value. Now I can use this system to actually tell me what the values are. So A to string, and in fact, let's do this. Put a little label in front of it. A equals, and then we can do the same thing for B. B equals. Now I'm using the statement write. Well, it turns out when we look at the output window that write is basically writing everything on the same line. So if I wanted to have A and B together, I would have to separate them out here. So now when I run this, I get my statement A equals 35, comma, B equals 5, because it wrote it out all in one line. But I also have an optional statement called write line. And what writeLine does is it appends any string that I'm writing out here with a carriage return line feed at the end. So in that case, I don't actually need this to separate it here. I can simply take this and do a writeLine as there as well. And now it'll write the values A and B on separate lines. So here you can see that they're on separate. So if I go back into the application, notice that I have values A and B, and no matter how many times I click this, it's going to write out new values of A and B. So 55 divided by 11. So here we get to 55 and 11. So it's actually writing that output to that window. And I can write whatever I want to out to that debug window and process that any way I need to. Now, the debug assert is actually in place of something like this where we might want to check this and actually prevent an application from doing something very, very horrible. So, for example, let's say I have business logic here, but I know this statement right here is vulnerable to, a value of B being 0. And let's just say this was a mission critical application, and it's better for the application to actually stop working or to allow us to deal with it in a different way than it is to allow the application to continue. Let's say, for example, I had a statement, delete all customers where state equals such and such, Indiana. Okay. Well, it turns out that maybe that isn't really what I wanted to happen, and maybe it's I'm looking for specific criteria, but we find out that, hey, there's some random string that can be placed in here that can cause this thing to delete all the records. So in that case, we definitely don't want to allow that code to execute. So we can actually use a debug assert, System.Diagnostics.Debug.assert, and an assert actually checks for a condition before it actually throws whatever the exception is going to happen. And in our case, we're checking to see if the value of B is equal to 0, okay? Now, if B is equal to 0, then this condition is actually not going to get triggered. So one of the things about an assert, it's unlike an if statement. It's kind of backwards from what we expect it to be. So we're going to assert that that's equal to 0, so div by 0 is our assertion statement. So I just basically added an assert statement saying, hey, we're dividing by 0. Now remember, this checks condition. If the condition is false, the output is going to be specified. So in this case, if this is false, so we want to check to say, if this is false, which B equals 0, this is kind of backwards now. Let me just go ahead and run this and show you what we mean. So here we run the code. Notice that it triggered this. It triggered it because the condition is false. It's backwards from what we're thinking of. Okay, so what we want to do is we want to say is not equal to 0, and actually there we go. So if this condition is false, then we'll go ahead and trigger that. So now when I run this, it works. But if the value is 0, this condition becomes false. 0 is not equal to 0, right? That's false. We get the actually I got a trigger that caused it to ignore that because of our logic. So let's comment this out. And I'm just going to go through here and comment all of those lines of code. This is a block comment, so we can comment those lines of code and we can uncomment them in one swoop there. So now when we run our code, if we put a 0 in there, now I get my assertion. And you'll notice that the application fails with this assertion fail, so we get to quit, abort, retry, and ignore error. So in this case, if I ignored this, it's going to try to do that division and actually throw the exception by 0. It's going to throw the division by 0 there. So that's a debug assert. Now a debug fail, which is the same thing as an assert, basically has no condition. So it's always, if this line of code gets executed, the application is failing. It's going to stop right there no matter what. So when I click this, it's just going to hit that line. Actually, I have a breakpoint there. So it's automatically going to hit that line of code and automatically going to display the stop dialog. So this is basically forcing the application to stop with a message. So that's in a debug and assertion. Now it turns out that we have the ability to create our own listeners. So when we were writing our code earlier, as a matter of fact, when we run our code, we actually get this output here in the output window. And that's because Visual Studio has what's called a trace listener built into it. and the trace listener knows to pipe all of its output out to this window. Well, it turns out that we can actually write our own trace listeners in Visual Studio and actually use them in our own code. So let's say, for example, that you wanted to have debugging statements in your application, but instead of sending them out to this output window, you wanted to send them to a database store or something like that. So what you would do is you would basically build your own trace listener in Visual Studio to deal with that. So I'm going to actually do just a few lines of code here that are going to show you how you can actually build a trace listener. So I'm going to say using System.Diagnostics. So we're using that System.Diagnostics namespace. We're in our basic debugging namespace. We're just going to go ahead and put a class right inside here. So we'll just create a new class right here. So our class is going to be a custom listener. So we're going to call it custom listener. And our custom listener is actually inheriting from System.Diagnostics.Trace listener. So we're creating a new trace listener basically. And our trace listener needs to actually implement three major things. It actually only needs to implement two. It needs to implement write and write line in order for it to work. So what we'll do is we'll say, let's do a public override. We're basically overriding the default write method. So void write. And actually we have object, right? I don't want object, I want string. I want the version that's specifically for a string. And we'll just say, instead of sending it out to the debug console of Visual Studio, let's just go ahead and do a system.windows.forms.messagebox.show message. And let's just say, I'm just using the write there to actually indicate which version of the method we're calling. So we're calling write, and then we'll do a write line. Okay, so let me build this and make sure everything builds just fine. Already contains a custom listener. Oh, sure does. Let me delete that. There we go. Debug, build. There we go. So I built a new custom listener. Line. There we go. We want this to say line. There we go. Bug, build. Okay, everything works. Okay, so I built this new custom listener that's basically replacing the write and the write line methods. In our case, it's simply going to show a dialog box as opposed to sending it to Visual Studio. And now all I need to do is go up here and tell my application to go ahead and use my custom listener instead of the default listener that it was using. And the way we do that is we can simply go into System.Diagnostics. And in our System.Diagnostics namespace, we have a class called trace. And trace actually contains, if we scroll down in here, we see a whole bunch of trace listeners. There they are. There's our collection of listeners. And I'm just going to basically tell it to go ahead and clear out all the existing trace listeners that we have. So this removes the existing trace listener that we have. And now we'll just go ahead and add our new one back to it. So listeners.add, and we're just going to create a new custom version of our listener. So that just basically removed the old one and added our new one instead. And we have our debug statements down here. So we have the 4 debug statements. Now I'm actually going to cheat just a little bit here. I don't want to see 4 dialog boxes. So what I'm going to do is I'm going to comment these 2 out. We're only going to see 2 dialog boxes this way. And I'm actually going to say copy, paste, plus. I know that's bad habit there as well, but we'll explain that later on. But we'll go ahead and run this. And now when I do my calculate, instead of the output showing up in the output window, I'm going to get them as dialog boxes. In this case, I wrote a write line, A equals 35, and a write line, B equals 5. And the calculated value is 7. So in this case, I totally replaced the way Visual Studio is intercepting it, and instead of passing it into the standard Visual Studio trace listener, I've actually passed it into my own custom trace listener so that I can deal with it however I want to deal with it. And that's basically the minimum that you need to build your own trace listener. Now, of course, you could also do things like the public override, void, fail, for example. So here you could build the fail message as opposed to the big ugly dialog box that they were showing, display the nice new dialog box that I built. So if we go back up to our fail window, boom, boom, we run this code. I get my A, 5, and now I get my divide by 0 because that line of code executed. And again, assert, and then in our case here, we're going to check to see that B is not equal to 0, and this will only execute now if B is not equal to 0. So that doesn't execute when I put in a 0 in here. Now I get my division by 0. So I did my assert, and I was able to capture that without the application, having to deal with it. Okay, back over to our code over here. So Horace is asking, is this how you would implement something like an error log for an application? This is partly the way you would do it, yes. So we're only halfway there. We have not talked about exception handling yet. That's actually in a future episode. But the try-catch block would be a way to capture all kinds of exceptions that would prevent the application from continuing on. Generally what you want to do is you want to be able to avoid throwing in an exception at all, if at all possible. An exception is just that. It is the exception to the rules. It turns out that there are a lot of issues in an application that can occur that are not exceptions, but simply violations of the business rules. And you want to make sure you understand the difference between that. An exception is something that's going to crash the application. A business rules violation doesn't necessarily crash the application. For example, you could say something like, I have a list of customers, and I want to display the list of customers. And if you're iterating through a loop of the list of customers, generally when you're saying you're iterating of it, you're expecting at least one customer in that list. But what happens if there are 0 customers? It's a perfectly valid scenario in your business logic to have a scenario where there are no customers, especially when the app is brand new. So it's perfectly acceptable to have business logic that says, hey, if there are 0 customers, take this action, otherwise take this action. That is not an exceptional case. An exceptional case is where I was dealing with, 50 customers, and then all of a sudden my memory got corrupted, and now I only have 37. Okay, now something happened that's violated the integrity of this system, which causes an exception. So exception handling and errors or business logic violation handling can be represented the same way in your system, but they might have different severities, for example. But you could use a debugging system like this, yes, to actually record that information out and create an error log, if you will. So great question. One other feature, the last feature we're talking about today in C# is this concept that's actually relatively new to C# that's called edit and resume. Visual Basic has always had the ability to edit and resume. So when you build an application, you were able to debug it, stop it, change it while it was paused, and then continue execution. And that's actually a really, really handy feature if you want to quickly debug or quickly fix an application. You can clearly see there was always a silly typing mistake that you caused. Well, there's no reason to go through all of the compilation process and everything is required to redo the app, when instead you can simply go back and fix that one minor error and then continue on. And edit and resume, or edit and continue, depending on how you term it, is basically gives you that ability to do that. And that's a feature that's available in some versions of C#. It's not available in all versions, and it's also platform dependent. So let me show you what edit and resume looks like within Visual Studio. Okay, now the first thing that you want to be aware of, let me just go ahead and remove, I'm just going to go ahead and remove our diagnostic information because we don't need that for this portion. Okay, actually let's go ahead and remove these as well. Okay. So if I run the app, it should run normally. Good. If I go ahead and put a breakpoint, let's put a breakpoint here and run it. I get to the point where I click calculate, the application moves over and pauses. Let's say I moved past that line, and I realize, oh, I didn't want to do A divided by B. I wanted to do A times B. With edit and resume, I can simply go back up to this code and actually type in a new value. Now watch what happens with Visual Studio. In fact, this is something that you want to be very, very careful of. I'm going to actually intentionally cause a dialog box that you don't really want to see. Hit star, you'll see that, hey, changes to 64-bit apps are not allowed. Visual Studio can only do edit and continue on 32-bit apps, C#. In Visual Basic, it can do it on 64 and 32. But for some reason, the 64-bit version of C# don't support this. But that doesn't mean you have to stop everything you're doing and start all over. In fact, Visual Studio actually has, basically we can tell it, go ahead and use the x86 version of the framework for our application. And the way we do that, it's not obvious in C#, but in C# what we do is we go into Tools, Options, and we go to Projects and Solutions, and you'll notice that we have this Show Advanced Build Configurations. That checkbox is disabled. And the reason let's just go ahead and enable that, and I'll show you what that actually enabled. So we're going to hit OK on that. And now that we've enabled that, what I can do is I can go to my solution and go to Properties, and we go down to Configuration Properties. Notice that we have our project, our configuration, and the platform that we're targeting. But the problem is the platform that we're targeting is set on any CPU. Because I'm running this on a 64-bit machine, it's building it for the current CPU that I'm running on. Remember, the .NET Framework likes to target this particular framework that you're running on. And when we're debugging, this is only an issue when we're debugging, so you'll want to change this back later on. Especially in your release configuration, you change it to whatever you need. But for debugging purposes, what I really want this to be is on the x86 platform. So what I'm going to do is I'm going to go into Configuration Manager, and you'll notice that in Configuration Manager, by the way, this is not available to us without that advanced mode. What I want to do is choose this active solution platform. It says any CPU. I want to create a new platform, and I'm going to choose the x86 platform, not any platform. And we're going to just set the empty settings. We don't want to copy the x86. We just create a new one, hit OK. Now that's changed that to the x86 platform, okay? When I hit close, we're now back over to the x86 platform for debugging. Hit OK to apply that. Now when I run the application, hit calculate. Let's go back to the next line of code. I can now go back and hit star, and it will allow me to edit and continue. So now when I drag this line pointer back up to here, remember A is 35, B is 5. Currently C is 7, but when I reprocess this, now look at that. C is now 175, which is 35 times 7, or 35 times 5, sorry. So 35 times 5 is 175, and now I get my new result. So instead of having the division be in the math, now we have multiplication. So, 25 times 5 is 100, let's go ahead and F5 that, 125. So I was able to edit this line of code and then move the next statement pointer back to it and continue on. Not only can I do it in that manner as well, I can also do it from here. So here I can say, okay, let's add a few more lines of code. So C equals C plus 100. So my next line of statement is still the multiplication, but then I'm going to add 100 to that value later on. So back over to our code, when I run this, I'm getting a much larger value. Now my value is 275 because it's 35 times 5, which is 175, plus the 100, which is 275. So in that case, I was able to pause the execution, add a new line of code, and then continue that. So that gives you, hopefully gives you a good idea of what edit and continue does. And how that actually works. And remember, on Visual C# 2010 Express, you simply need to create that new platform, x86. Once you have that created, you can do your edit and continuing. Okay, so in this session, we actually covered what a bug was. We've learned about debugging and how we can actually use Visual Studio's advanced features to do this. Now, I do want to point out that we are using the C# Express editions, and they have a very, very simplified version of debugging. We actually have some very, very powerful debugging features in the more advanced versions of C# and Visual Studio. that can do some amazing things. And if you're using any of those versions, I highly recommend you take a look at some of the other videos that I've done in the past about the advanced debugging features of Visual Studio. Next week, we're going to talk about arrays and collections. We're going to see how we can take, for example, our customer and turn it into a bunch of customers, and how we can actually deal with those collections of objects within our code. Again, as always, thank you for watching this session and all the others. Feel free to follow me on Twitter at WJ Steele. It was pointed out to me that there's an issue with my blog, but keep an eye on my blog. I will have it fixed here in a few days. They actually had an accident that went through a script that ran wild on when they converted me over from one server to another, and it only converted part of my data, so my blog looks like it's kind of out of date right now. But we'll get it back up there with all the demo code. And at this point, I want to go ahead and turn it back over to Sydney where she can get you into the survey. Please, please, please fill out that survey and let us know how we're doing, what you'd like to see us do in the future, and any comments or questions that you have around, general webcasting in general. Sydney?
Thank you. I'd like to remind everyone that you can print a PDF of the slides by clicking Control-P. You can either print or save the slides locally for your convenience. You should all be seeing a survey now in your slide area. If you could take a moment to fill it out before you log off, we do appreciate any feedback you leave for us. All you need to do is follow one of the 3 links provided to complete the evaluation. And with that, I'd like to extend a special thanks to Bill for today's presentation. Thank you all for joining us. You may now disconnect from the audio portion of today's conference.